Solve by graphing. 4x minus y equals negative 1, and 2y minus x equals negative 5. We need to graph both of these lines, and the first one, 4x minus y equals negative 1, we could use the intercept method. But the problem with the intercept method is that we're going to have an x-intercept that's very small, and also a y-intercept that's very small. And if we have x and y intercepts that are small, it's difficult to really connect them and have an accurate graph, especially when I'm drawing on the iPad. So what I'm going to do is I'm actually going to get this into slope-intercept form because I think it's going to be a little bit easier to work with. So we've got 4x minus y equals negative 1. To get the y alone, we need to subtract 4x from both sides. This leaves us with the opposite of y, or minus y on the left. We've got negative 1 minus 4x on the right. Now we want y alone, but it's got a negative sign in front of it. So to get rid of that, we're going to divide both sides by negative 1. This is going to give us y on the left, and on the right, a negative divided by a negative is a positive. So we're going to have 1 plus 4x. And it's fine to leave it like that, but if we really want to put it in slope-intercept form, the slope comes first. So we could rewrite it as y equals 4x plus 1. Honestly, either one of those is going to work because we can see that the slope is the coefficient on the x, which is 4. And we can write that as 4 over 1 if we want. And the y-intercept is the constant term, which is 1. That's going to give us 0, 1. So when we graph this, we're going to start at the y-intercept, which is 0, 1. And then the slope is 4 over 1. So from the y-intercept, we're going to rise up 4 and run to the right 1. We're going to go up 4 and go to the right 1, which is a little bit off the plane, the part of the plane that I've drawn, but we can still put it there if we want. Now here we're going to want more points, so we're going to start again at the y-intercept, but we're going to go down 4 and to the left 1. Down 4 to the left 1. And when we connect these dots, that gives us our line. All right. Now you could have used the intercept method here. If you had done that, you would have gotten an x-intercept of 1 and a y-intercept of negative 1/4. But see how these 2 points are so close to each other? It's really difficult to get accuracy further out with those points. So you could definitely try it, and maybe if you are an excellent grapher with a good ruler and you're very accurate, you can draw that accurately. But in a situation like that, I think it's better to use slope-intercept form. Now let's go to the other equation. That other equation is 2y minus x equals negative 5. Here we can use either the intercept method or slope-intercept form. Since we've already used slope-intercept form here, let's use the intercept method. To find the x-intercept, we let y equal 0. If we do that, we've got 2 times 0 minus x equals negative 5. And 2 times 0 is 0, so that term just vanishes. And we've got the opposite of x equals negative 5. To get x alone, we divide both sides by negative 1. And we end up with x equals positive 5. Because a negative divided by a negative is a positive. So we've got 5 for the x-intercept, which we can put right there. And then for the y-intercept, we're going to let x equal 0. If we do that, we've got 2y minus 0 equals negative 5. Now, 2y minus 0 is just 2y. So we have 2y on the left. Now, to get y alone, we divide by 2. This gives us y equals negative 5 halves. And we don't want to leave it like that because we need to figure out where that goes on the y-axis. So we probably want to convert that to a mixed number or a decimal. If you convert it to a decimal, it's going to be negative 2.5. As a mixed number, it's negative 2.5. Now, either way on the y-axis, to go to negative 2.5, we've got to go down 2 and then halfway further between negative 2 and negative 3. So 2.5 is going to be right there. And if we connect these dots, let's see, I'm not doing this as accurately as I could. Again, it's difficult on an iPad. But if we connect the dots, we see that these two lines do intersect. And in fact, it looks like they intersect at the point negative 1, negative 3, because that's to the left 1 and down 3, which tells us that our solution is x equals negative 1 and y equals negative 3. If you plug each of those into the original equations, they should give you true equations, verifying that the answer is x equals negative 1 and y equals negative 3.